We spend our lives inside rigid, static boxes. Most modern homes are neutral containers, four walls and a roof designed to hold furniture, which ignores the ancient biological systems running inside of us. Before you wake up and form your first conscious thought, your physical environment has already begun communicating with your nervous system. Constant, harsh overhead lighting and echo-heavy acoustics create invisible friction. Because the space itself cannot change, your body is forced to constantly adapt, draining baseline mental energy hour by hour. This is the focus of neuroarchitecture. It treats interior spaces as active biological interfaces rather than simple shelters. To thrive, an environment must stop forcing the nervous system to adapt to rigid walls and instead be engineered to adapt to our biological needs. Human biology requires a light source that changes throughout the day to remain in sync. In the morning, exposure to cool, volumetric daylight triggers cognitive focus and wakefulness. A standard workspace often provides a single, unchanging fluorescent glare, which interrupts these natural rhythms. Adaptive homes use dynamic lighting to mimic the solar cycle. This chart shows how an automated system maintains a high 5500 Kelvin baseline in the morning to support alertness. As the day ends, the system triggers a shift to a warm, indirect 2700 Kelvin baseboard glow. This specific amber spectrum allows for natural melatonin production, signaling the brain that it is time for rest. In an adaptive home, lighting functions as a time-bound biological interface that synchronizes brain chemistry. Beyond the passage of time, our spaces must also account for the variation in human personalities. For a highly sensitive individual, an aggressive, high-friction open-plan room causes immediate physical posture tension. Adaptive architecture utilizes distinct, specialized microzones that instantly offer much-needed sensory relief from these aggressive, high-stimulation environments. Integrating sound-dampening wool upholstery and slatted timber absorbs echoes, lowering sensory input back to a comfortable biological baseline. When a space respects these neurological limits, the body can finally disengage its defensive response, allowing the home to support genuine recovery. Physical movement is the next layer of the blueprint, specifically the removal of spatial friction. Spatial friction is the quiet stress caused by rigid floor plans and cluttered pathways that block natural human behavior. Adaptive homes use built-in hidden mechanics to smoothly transition room functions, effortlessly revealing or concealing entire workspaces as needed. Using elements like pocket doors, a single pavilion can transition from an open, sunlit workspace into an enclosed evening gathering area. This diagram illustrates a deliberately engineered path, dissolving the points where movement typically stalls and replacing them with fluid channels that route effortlessly around modular furniture. When architecture anticipates human behavior, the space supports daily life without requiring conscious effort. This approach creates a home where indoor elements, outdoor environments, and dynamic lighting operate in unison in the background. By applying the science of environmental psychology, design functions as a regenerative framework for the inhabitants. An environment designed this way changes with every hour, season, and chapter of life. Applying neuroarchitecture creates a home that supports the internal state of the person inside it, acting as the foundation for a life well lived.